By request, I have this example for you. It involves solving an equation for x where there is a polynomial and there's an absolute value sign, and you have to solve for x, and you're allowed to use a graphing calculator to solve it. Now, it's pretty simple when you're allowed to use graphing calculators, and what your teacher may have, or what your school may have forced you to do, is buy an expensive TI-83 calculator or TI-83 Plus, instead of, using free online tools that are freely available on the internet, but I won't get into that. The point is, on your test, you'll be using probably your TI-83 or your TI-83 Plus. And in it, you have to plug in some equations so that you can get the graphs that you need to solve the problem. So, on the left side of the equation, we have the absolute value of x plus 4. And on the right side of the equation, we have x cubed plus 3x squared minus 9x minus 20. And we have an equation. So how do we solve this? Okay, so we have our TI-83, and you're going to hit your graph button. And once you do that, you'll get a list of y1 equals, y2 equals, y3 equals, and so on. In y1 equals, you're going to enter x plus 4. So this is the absolute value, but first we're going to ignore the absolute value sign, and we're just going to enter x plus 4. And then for y2, we're going to enter negative, open bracket, x plus 4, close bracket, to get the other side of the absolute value. And then in y3, we're going to enter the right side of the equation, x cubed plus 3x squared minus 9x minus 20. Okay. How is this going to turn out? Okay, so when you enter your equations, and then you go to the graph on your calculator, it should look something like this. Something similar to this, where you've got your first line goes straight up like this. Your second line goes downward like this. And then your third equation gives you a squiggle like that. Your cubic function. Okay, so how do we handle this? Let's just zoom in a little bit here. First thing we need to notice is that since we're dealing with absolute value, the absolute value of x plus 4 is only going to be the parts of the straight lines that are above 0. So it's anything in the positive area. So it's this part of the downward slope until it reaches this point, and then it's the upward part. So all the stuff down here we can ignore, because absolute value does not yield negative values. It only yields positive values or 0. So all of this stuff down here can be ignored. Excuse me. Okay, so we need to find our intersection points. So where does this V intersect with the squiggle? Well, let's zoom into this first point, which appears to intersect, and it does. So on your TI-83s, you're going to select a point maybe over here, select a point over here, and then tell the calculator to find the intersection between the two curves. And it's going to be right here, negative 4, 0. So x equals negative 4 is going to be one of the solutions. Okay, well, how about some other solutions? Just follow the graph, we find, oh, there's another intersection point. and we find that there it is, negative 2, 2. So x equals negative 2 is another answer. And then we continue on, zoom out once again. Oh, there's another intersection point. It's up here. Zoom in. What do we got? 3, 7. So x equals 3 is another intersection point. So those are our answers. X equals negative 4, x equals negative 2, and x equals 3. Now it's a good idea to try each of these values back in the original equations. Or the original equation, just to see that it's going to work. So remember, negative 4, negative 2, and 3. So we're back here again. If you plug in negative 4 into here, and negative 4, negative 4, negative 4, you'll see that it works. 0 equals 0. Now if you plug in negative 2, negative 2, negative 2, negative 2, it also will equal one another. You'll get 2 on this side and 2 on this side. And what about if you enter positive 3? Well, 3, 3, 3, 3. You'll get 7 equals 7. So that's how we verify that these three answers are correct. Negative 4, negative 2, 3.